everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze a mobile phone stand. This is a 3-session series in which we will be analyzing 3 different types of mobile phone stand. This is the first lecture in that series. So we will start by double clicking on static structural. We are going to do a simple stress test analysis of a mobile phone stand. I'll first go to engineering data sources. I'll choose general materials. Now here you can use any type of material for the stand. If you look at the market currently, you would find that aluminum alloy is used. Stainless steel could be a material that is used, and if it is made of plastic, then I can choose polyethylene as the material. I have bookmarked all 3 of them. I'll go to projects and update project. All the materials have been added to engineering data. I can use them and check what would be the stress generated by each material when it is subjected to a particular amount of load. Next, I'll go to geometry. I already have the stand made with me, so I'll go to import geometry, and this is the first model that I have with me. So I have imported the geometry. Next, I'll go to model and double click on it. This is how the model looks like. I'll just align it a bit. Next, I'll go to geometry. I'll choose the model. I'll change the assignment of the material to say polyethylene. It's a plastic which is generally used for making such kind of mobile stands. Next, I'll go to mesh. I'll change the sizing. Relevant center, I'll make it to fine. In case your version doesn't allow for changing the sizing, you can just change the element size over here. Default is 0. You can change it to 0.01 or 0.001. If you have a very good processor speed, you can use very fine elements as well. So I have chosen fine and I'll go to update. Next, I'll go to static structural, and first I will insert fixed support. Now when you place the stand on a table and then you're going to place the mobile phone on the stand, so obviously these ends now become fixed because they take up the velocity of the table, which is obviously 0, which means I'll take it as fixed. I'll press Ctrl and select all the 4 surfaces. Apply. So it is 0 velocity now. Now when you place your mobile phone over here, you need to apply some force on the area on which your mobile is going to align itself. So on this surface and on these surfaces, I'm going to apply the force. Now if you look at the geometry very carefully, you will understand that the mobile is going to align on this surface, which is approximately at 30 degree when you consider the central portion, not this edge but the central line over here. So if I assume that the weight of my mobile phone is approximately 150 grams, which makes it to 0.15 kg, and when I convert into Newton, I will approximately multiply with 10. You can multiply with 9.81 as well. So it becomes 1.5 Newton. So in that case, the 1.5 Newton, if you observe carefully, will be applied in a very aligned way. It's at an angle. So if you resolve, there will be one horizontal and one vertical component. So the horizontal component is going to show its effect on this selected side. So when I select this face and apply force on this face, I'll change vector to component. Now, since this is the side along which the angle is supposed to be seen, so this component, the component here, which is vertical, will be the cos component, and this horizontal component will be the sine component. So if you calculate 1.5 sine 30, it is approximately 1.48. So here I am going to give the force as minus 1.48 Newton. Okay, that should be along the z axis. So I'll write here minus 1.48. So you can see here the mobile will align itself along the surface. Also, it will exert force on these two ends, that is the seat of the mobile. So I will now insert force again on these two surfaces, and I'll change vector to component. Along the y-axis I will apply a force, so it will be 1.5 cos 30, which is 0.23, and it is vertically downward, so 0.23 Newton. Now once I have made my calculations and applied the forces, these are the boundary conditions, I will go to solution, right click, insert, deformation, total. I also want to see the strain which is happening on this body. I also want to see the stress generated by the material. So I'll go to solution and solve. So this is the deformation obtained on the body. It is 0.1 mm, which means it is really very small. Now the animation that you can see here is actually larger than life. So do not assume that there will be such a big deflection. It is actually very, very small if you read the value over here. Next is the elastic strain. You can see the amount of deformation that could happen in the dimension is actually very small, 0.00046, and the stress is also very less, 0.47 megapascal, which is exerted on these surfaces. You can see here where it is this blue, the value is very small at the least. Actually the value will be 0.000972. But when you see these edges which are fixed, obviously the stress will be more at that end, and at that edge, if it is red in color, it is 0.47, or if it is yellow, you can see here the color is 0.31 to 0.36. So that is a range of values over here. So accordingly, you can see that the stress generated is mainly in the areas where the load is more, the effective load is more, or the stress generated is more where the surface is fixed. So these are the areas that you can see. So you can just animate and check this result of stress, because this is the main reason for doing this analysis. And I have used polyethylene as the material, which is a type of plastic. If you want, you can change this material assignment to say aluminum alloy and solve it. You may also use stainless steel. Some people also make these stands of steel. So I can just use aluminum alloy because it will be cheaper and lightweight. So this could be a reason of using it. But if you check the stress value, I think the strain is lesser. We'll check the stress. The maximum stress is higher, but obviously these are the values of stress at different areas. So you can just check, and you would see that aluminium is providing more stress, that is more resistance to the amount of load being applied, and this is the strain value for aluminium alloy. You can animate and check the result. The effect shown will be the same. The maximum stress generated by aluminium alloy is a bit higher as compared to polyethylene. So with this, I end the session. I hope you have understood how to analyze the mobile phone stand for its stress test. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session with the second part of this analysis. Thank you.